Okay, so we're talking about basic PID control. And so when you look at PID control, we're going to draw a graph here. So if you look what happens in a normal scenario, you're going to go up, and then you're going to go down, and then you're going to go up, and you're going to go down across that set point. And what's happening is right here the heater's on at 100%, and right here the heater is on at 0%. But you have enough thermal inertia that your temperature is continuing to go up. So then eventually your thermal inertia reaches equilibrium and your temperature goes down and it hits the set point and the heater comes on. So right here you're at 100%, right here and right here. But because things don't happen right away in a vacuum, your temperature is going to continue to go down, and then it's going to come back up, and then right here you're on at 0% again, but again you have that inertia. So you're just going up and down and up and down all the time. So that's on-off control. Let's look what happens when you have PID control. So we'll take a fresh graph, and with PID control you're going to go up and you're going to go down, and then you're going to have a little bump, and then you're going to come in line with your set point. So if you think about PID, that stands for proportional, integral, and derivative. So we'll start with proportional. Right here, you're going to be at 100%. But then there's a band right in here. So the band is going to kind of come across like this, and it's going to come across like this. And when it gets into that band, it'll start doing 80%. And then on this side, it might do something like 20%. So instead of being 0, you're going to have some percentages available here. So, 80%, 20%, somewhere down here it might be like 15%. And so you get that proportional concept. Now if you look at integral is the area under the curve. So it's this area right here, it's this area right here, it's this area right here. And what happens is, as you look at that area under the curve, underneath the curve, the algorithms start to calculate that area and make it as small as possible. So they want it to be as close to 0 as possible, and that's how you achieve a finer level of control. So that's P and I, right? So you got your proportional, you got your integral, which is the area under the curve. Now let's talk about D, which is derivative. So if you remember high school calculus, derivative is the slope of the line. So you have this line right here, you have this line right here, you have this line right here, this line right here. It's also known as the rate of change. And so if you look at that rate of change, you want that to be ultimately as close to a horizontal line as possible. So as the P starts to dial things in a little bit, and as the I starts to look at that area under a curve and make it as small as possible, then the D kicks in and it takes that slope of line or rate of change and gets it really close to horizontal, and that's how you have true and complete PID control from a very basic standpoint. Thank you.